fascinating. But when you said if you have like an impermeable clay layer, wouldn't the pressure build up under it and then cause liquefaction instead?
That's a good point. Is if I have a impermeable clay layer with the shaking, I can get some cracking and the water can come through. What I'm really focusing on is the layers in between. So if I have a number of layers that are all a half a meter thick, but they're all separated by clay layers that are maybe only 30 centimeters thick, then the water that generates in each sublayer cannot communicate that water to the layer above it. Okay? And so by the time the water gets up to the clay crust, there isn't a significant volume of water to essentially cause the ejecta that you see at a clean sand site, where you've got maybe 8 meters of clean sand that's generating pore pressure and the water pressure is coming up, and all of that collects underneath that layer and then blows out, and you have a lot of ejecta. Wherever you have a lot of ejecta and you have lightweight construction, you have a lot of problems. So ejecta is one of the things I'm trying to focus on now, to better understand how we can predict when we have ejecta and not have ejecta, and then how much ejecta.
I'm going to ask a question. Obviously, Christ Church has really just been this amazing case history. You can dive into so many of these different kinds of issues. Are you concerned about, or what measures are being taken to ensure that transferability of this case history to other places, right? You got particle shapes and sizes and gradations and all of that, so how are we going to turn this into more general rules?
I actually had a teleconference with Short Band Allegory yesterday, and that's what we were talking about, is when you look at Christ Church, there are different geologies. And it's important that we're focusing primarily in this certain eastern suburb that has a certain type of geology, a certain type of soil, but we're bringing in geologies from other part of Christ Church, like Kaiapoi to the north and the Parkfield area, to look at those geologic differences. Now, they're all the footprint of Christ Church, and now we have to step back and start looking at Adipazari and bring that data in. We got to look at what happened in Wellington, and we have to look at other earthquakes around the world. So we're trying to think about that as we look at Christ Church, to understand differences in geology within Christ Church, and then we recognize that we have to then enlarge that, but that will be the next peer project.
Okay, very good. Okay, thank you. Very interesting. So.